Righto, Year 10, we're going to do our lesson for today, which is index laws. You can see on the schedule and on our online learning platform that today we are revising index laws. We've got to know our index laws. We need to know our index results, and we need to be able to apply them in the algebraic expressions. I'm going to do exercise 2F, 1, 4, 5, 6, 7, last column, then 8, last column. And we need to finish those for homework. So let's have a look at what these questions are all about. So I'm just better write that down so I don't forget it. Questions 1, 4, 5, 6, 7, 8, and we're doing the last column. Righto. So the first thing you need to know is you need to remember these index laws. Now I can go through and prove them, but you're going to need to write them down. And they're all here. And at some stage you will end up confusing these. But let's have a look at them just to begin with. So the first one, and you need to write these down, as long as we have the same base, that's an ugly A. As long as we have the same base, we're all right here. So A to the M times A to the N. Or when I've got the same base, I can just add the powers. Now, why does that work? Well, imagine if you had x cubed times x squared. Well, x cubed is x times x times x, and x squared is x times x. And then all of a sudden, I've got x, and I've got how many of these babies? 1, 2, 3, 4, 5. So it's x to the power of 5. And you can see there that that's just the same thing as adding those two, but they must be the same base. Now, by the same token, we can take a to the m divided by a to the n, which, by the way, is the same as a to the m over a to the n. And what we can do there, by the same process, is subtract them. All right? And again, if I had x cubed over x squared, that would be x over x. I was hoping that would change colour, but it didn't. And that one would go, and that one would go, and that one would go, and I'd just be left with x to the 1. Don't need the 1, but I'll write it up so you can see that that's what you would get when you did 3 minus 2. Now, the other one, power of a power. So when I've got a to the m times n, well, that means n repetitions of a to the m. So again, let's do this. A cubed squared, well, that means a cubed times, x cubed times x cubed. And if we use our first law, that's x to the 6. And there we go. We just multiply the powers. So in here, a to the m means that we're going to multiply. Normally I wouldn't write that multiplication in, but otherwise you might forget it. The other two, these two here, I'm not going to write them in because I'm not that fussed about them. They're pretty obvious. The other one I'm going to write, so there are index laws, our index laws. Right, they're the laws we have to follow when we're doing this. But we also have some index results. So these are things that happen when we have certain powers. So our index results are, if we have x to the power of 1, well, that's just x. That's pretty obvious. Index results. And if we have x to the power of 0, well, that's 1. 0 to the power of anything, well, that's 0. But hold on, we have a bit of a contradiction here. What about 0 to the power of 0? Well, we have a contradiction because we have two rules. So we're going to say that that is undefined. Later on, we'll probably be defining that as 1. All right, and that'll do us for now. We are going to learn some other results and other powers, but they're the main ones we're going to use for the moment. Now, please remember that to do those index laws, they all must be the same base. All right, so what are we doing? Question 1, last column. So these are pretty easy. These are just revisions of these. So last column, exercise 2F, no worries. What do we got? Here, 7, 1, 2, 3, 4, 5, 6. Oh, now you go and have a go at these. 7 to the power of 6. Now remember, with your numbers, I'll make this a bit bigger, with your numbers, when you do these, you just multiply the numbers. 2 times 3 is 6, and I've got x. How many x's do I have? 1, 2, 3. Oh, x cubed. And here, 2 times 4 is 8, and I've got a couple of A's there. We'll do the A's first, alphabetical, A. So we're going to use a sharper pencil, A cubed. And I've got a B and a B. Oh, that's B squared. Hey, thank you. All right. So when we multiply or divide, you just do the numbers on your calculator or in your head, and then put the letters in alphabetical order with however many there are. So now we're going to scoot along to question 4. Now, because you're going to do the last column, I'm going to do the first column. I'm going to do the first column. So you need to use these laws to help you do the first column. So here we go. I'm going to do 4A. You should be working along on the other one. So 4A, I'm doing the first column. You're doing the last column. A to the 5 times A to the 4. Oh, our first rule, add the powers, got the same base. A to the 9. It's too easy, Mr. Tonkin. Yeah. B, 7m squared times 2m cubed. Oh, 7 times 2, do that on my calculator. No, I don't need it. 14. And then I've got the same base, and I just add those powers, m to the 5. G, I've got a fraction here. Don't let it scare you. 1/5 p squared times p. And remember, our index result means that there's a 1 there, just in case you forgot. Well, there's only one number. It's a fifth. I'll leave it out the front. You could put it all over if you wanted. And I add the powers p cubed. All right, that's enough of those. I think you're going to be right with those. If you're having any problems, you need to send me an email. Remember, do the numbers on your calculator, collect all the letters, and away you go. So here, let's have a look at division. What have we got here? Again, I'm going to do the first column. So I've got 5A. What have I got? I've got division. Now remember, I can just subtract the powers when they've got the same base. So 5 minus 2, I get x cubed. The next one, b to the, so what have we got? D, b to the 5 divided by b. Remember our index result, there's a 1 there. And what do? We subtract them. So 5 minus 1 is b to the 4. Now, I'm glad the next one came up as a fraction, because there is another way to do this. If you do these as a fraction, which is how I tend to do them. Now, I can subtract those numbers if I want, or I can cancel. So 6 of these j's cancel with 6 of those j's, leaving me with 1. So it means I get j to the 1 up there, but I don't need the 1. And that's cancelled. Oh, but Mr. Tonkin, isn't there a... Oh, get back here. Isn't there a 0 there? No. When you cancel, you're saying how many times does j go into that? J to the 6 goes into that once, and j to the 6 goes into that j times. All right. So again, that division should be right. How about? Oh yeah, let's do 5j, because that's going to be hard for you when you're doing 5l. We'll see how you go with that. So here's j, and I've got 3r squared s r to the 5. R to the 5 s squared. I'm going to write it as a fraction because I like cancelling. You don't have to write the division the same way they write it. And then I just cancel. Or one S goes, three R's go, and with two there, and away I go. So what have I got left? On the top, I've got 3R squared and an S, and underneath I've got a 1, but I don't need to write the 1, so I'm going to let it go. 6, power of a power. Power of a power, so 6A. Oh, this is pretty easy, and you should remember, because we did do this last year, x to the 5 squared, multiply the 5 and the 2. You multiply that, so x to the 10. What's the next one? Now, here's where you will make a mistake, because some people for some reason just want to ignore the 4, which is wrong, because that's 4 cubed, and then the t, well, t squared, 3 lots, 6. And you should know your cubics. 4 cubed, I'm pretty sure, is 64. And t to the 6. And I'll just double check what I'm up to. Yep, there we go. So let's have a look at m. Actually, I'll do p, because I reckon you're going to have trouble with p. What have I got? 4p squared q cubed to the 4 all over 3r squared. Now, 3r. Remember, all you're doing is you're raising every term there to the power of 4. 4 to the power of 4. 4 to the power of 4. I'm going to need my calculator for that one. 4 to the power of 4. 256. So I get 256. P squared to the power of 4, multiply the powers, p to the power of 8. Q cubed to the power of 4, multiply the powers, q to the power of 12. 3 to the power of 4, I'm pretty sure that's 81. And r to the power of 4, r to the power of 4. And I'm just checking, and, oh, that must be a 2, not a 3. Oh no, it is, it's right, 81r to the power of 4. There you go, and that's correct. Woohoo! Okay, so 6, 7. Now remember, anything to the power of 0, but be careful, it's only the thing to the power of 0. So if I look at 7a, 8x to the 0. Well, the 8's not to the power of 0, only the x is. So that becomes 1, and 8 times 1 is 8. B, I'm going to do all these, are pretty easy. 3 times t to the 0. Well, the 3's not to the power of 0. It's 3 times 1, which is 3. C's really easy. C's really easy because 5z to the power of 0. And it's all to the power of 0. So that's just 1. That's just 1. I'll do G, and you've only got to do H. G, 4b to the 0 minus 9. 4b to the 0 minus 9. Well, the 4's got nothing to do with it. B to the 0 is 1 and minus 9. Well, 4 times 1 is 4. 4 minus 9 is negative 5. And we'll just check there. Beautiful. So you should have no worries doing those ones. Let's have a look at some of these from 8. Most of these you can do pretty easily. I'm just going to rub out some of this so I can create some space right near the question so I don't have to redo it. So let's have a look at some of these. So I'll just do the first column. You're having a go at the second column. Well, you can go and have a go at them. I'm going to do them anyway. I'll do the second column. You go and have a go at these. So what have we got? X squared y divided by xy times y squared. I'm a fan of cancelling. It's just how I work. You might do the subtraction, then do the addition. It's just easier, I reckon, do the cancelling. That y goes, that y goes, that x goes, that goes. Oh, I'm only left with things on the top. X squared, y squared. What question are we doing? This is 8b. So I'm just checking my answers as we go. Yep. The next one, D. It's already set up as a fraction, so I like that. X squared y cubed times x squared y to the power of 4 over x cubed y to the 5. Now remember, this is set up as working, so really try and make this clear. So I get rid of 5 y's on the bottom. There are 4 there, and I'll take 1 from there, so I've got 2. And 3 x's from the bottom, so take 2 away from there and 1. Oh, so now all I've got is an x to the 1, I don't need to write the 1, and a y squared. But you've got to show that cancelling. So what was that one? D, 8D. Yep. Let's go down here and have a go at a really hard one. So 1, 2, skip a few. We'll go down to L. What have we got? 4 f squared g to the power of 2 times f squared g to the power of 4 all over, oh, I've got some other ones down here, get rid of that, all over, because it's divided by 3 fg squared cubed. Righto, so we'll tidy up the top first. 4 squared is 16. F squared squared is multiply the powers, f to the 4, g squared times f squared g to the 4. And on the bottom, that 3 is untouched. It's not part of the cube. Only the fg squared is part of the cube. So the 3 just hangs there. F cubed, g squared cubed. I'll multiply the powers, g to the 6. And now I'm going to cancel. Well, I can't cancel any of the numbers, like 16 and 3. Nothing goes into each of those. But I can get rid of all the g's. Look at that. Those g's go. 6 from the top, 6 from the bottom. And the f's, 3 of these go. I'll take 3 out of there. So what have I got left? Well, I've got my 16 on 3. Now, you've got a choice now. You can either keep the f's on top, or you can just put the 16 on 3 out the front. I'm going to write 16 on 3 out the front. I've got an f to the 1, an f to the 2. I'll add those powers, and I'll get f cubed. And I'm looking at that. Yep, 16 on 3, f cubed. All right. And was that it? Was that the last question? Let's just have a quick look at the web page. Yep, 8 was the last one. So let's go back. Have we done the 8? Beautiful. So that's work we're doing today. Good luck with that. And see if you can do it on your own. If you have any questions, make sure you email me.